Okay, notes on relative dating. The crust of the Earth is constantly changing due to natural forces such as tectonic forces and weathering. Remember, tectonic forces are the forces of the giant plates of the Earth's crust moving around, and weathering is the breaking down of rocks into smaller pieces, sediments. A primary role of geologists is to use the data found in rocks to reconstruct the order of geologic events that shaped an area. This is the relative age. That things happened, not exactly how long ago. If we say this rock layer is 3,000 years old, or this layer was made by a volcano in the year 1000 BC, we are stating the absolute age, and that's for another chapter. We're just looking at relative ages, meaning this layer is older than the next layer. If we say this rock layer is older than that one, or this rock layer formed first, we are stating relative ages. There are 6 different basic ideas that we need to understand. Principle of uniformitarianism, principle of original horizontality, the law of superposition, the law of cross-country relationships, unconformities, and inclusions. One at a time now. The principle of uniformitarianism. Current processes are the same. The same as they were in the past. However, their rates may vary. Examples. Volcanoes have always been active on Earth. However, some years there may be lots of eruptions, and some years there may be no eruptions. This is an assumption. I'm talking about the principle of uniformitarianism, the idea that processes in the past are the same as they were today. Okay, that's an assumption that cannot be proven. It may not be true. This is not an unreasonable assumption, though, but some people may disagree with it. Principle of original horizontality. Rock layers are deposited in flat layers. Flat, horizontal layers. Flat, horizontal layers. Any tilting or wiggling erosion at the top of the layers happened after the depositing. Layers are often called stratum for singular, or strata as a plural. So if we see one layer of rock, it's a stratum. We don't say stratums if there are several layers, we say strata. A bedding plane is a contact border between strata, between layers. These may show erosion or contact metamorphism. Contact metamorphism means that at the boundary, the rocks have been changed due to pressure or temperature. Some bedding planes are nice and straight. This probably means that one type of rock was made directly on top of another layer. If there is a boundary between rock layers that's not uniform, meaning that it's not straight and level, then something like erosion or faulting probably occurred in the past. These are known as nonconformities. Or you might see unconformity. Either way, non or un, anyway, it means that it's not uniform, not smooth. Examples of erosion include rivers and wind. And let's see here, what else could there be? Just runoff. And you can look at this video to see a video on erosion. Okay, the third basic idea that we need to learn is the law of superposition. The closer a horizontal stratum is to the surface, the younger it is. Another way of saying it is, the deeper the layer, the older it is. And that makes sense. When you first did the rice and beans project, and you first laid down the brown rice, and then a moment later you did the white rice, and then a moment after that you did the beans. Well, the brown rice, the first thing you put in, is at the bottom. The last thing, the most recent addition, are the beans, and they are on top. Letter D. Law of continuity says matching rock layers on opposite sides of a feature are the same age. So for instance, you might have a bunch of layers like that. I'll put dots on that layer and little hash marks on that layer. These are layers of rock. And then let's say a river develops and cuts down into this bunch of rock layers and makes a valley like that. Well, what that ends up with after many, many years is that you're going to have a valley that looks like this. And over here on this side, we have the dotted rocks. And over here, we have the same dotted rocks. And down here, the hash mark rocks. And over there. So on opposite sides of the valley, we have matching rock layers. Letter E. Law of cross-cutting relationships. A fault or an intrusion is younger than the rock layers that it crosses. So let's say that we have a layer of rocks and then there's a giant crack down through them. Well, we know then that these three layers must have been laid down as continuous rocks, and then afterwards we get the crack. The crack happened more recently than the depositing of the three layers. That makes sense. You can't have a crack in layers until after you have the layers. Letter F. Law of inclusions. If a rock fragment is found in a sedimentary layer, the fragment is older than the sedimentary layer. It's sort of like saying that in a chocolate chip cookie, the chocolate chips are older than the cookie because you have to go to the store and first buy the chips before you start making the cookies. So the chips might be made on Monday, you don't buy them until Friday, and then you make the cookies on Saturday. So obviously the chocolate chips have got to be older than the cookie itself. Okay, the last two laws give students the most problems. That's these two here. Okay, the following is called a geologic column. Different patterns show different types of rocks, not individual rocks. In other words, this here is not an individual rock compared to this one over here, compared to this one down here. I'm just saying that this general area with the brick-like pattern is one kind of a rock. And then these up here with these horizontal slashes, that's a different kind of rock. And then this is yet a third kind. Okay, so label the features in order of formation. Okay, so the lowest rocks are usually the oldest. So this layer here is the first. And then we see this must be like some lava that worked its way up and then formed a pool on top of those rocks and then solidified into solid rock. So that's number 2. And then after that pool was solidified, then we have some more layers on top of that. So that was layer 3. All right, so in this situation, again, we'd say that the lowest level is the oldest. That was formed first. So we're going to put number 1 there. And then the layer above that, 2. And the layer above that, 3. And then letter F would be the 4th. Now we assume that those were laid down nice and flat originally, but now they're bent. so after they were laid flat, then we have to assume that some forces came around, tectonic forces or whatever, and bent these rocks. And so number 5 is going to be bending. And then we have what should have happened was we should have had nice little rounded hills, so to speak, but we don't. We have this jagged thing, and part of F was cut off. And so number 6, the 6th thing that happened was erosion. We can tell it's erosion because of the wiggly line here between the layers, and that some of the features have been cut off. It's not nice and smooth like these boundaries here. Okay, then after the erosion, then we had that layer, and then this one, and then this one, and then this one. So those are the 10 steps. And here we have some erosion going on up here as well. We might want to add that, number 11, erosion, if we so desire. And that's the end. So, please do the wrap-up and homework 51 in the Schoology.